Hello people, welcome back, and today we're going to be looking at more practice questions. Specifically, we're going to be looking at chapter 9, and we're going to be looking at the topic on cracking hydrocarbon chains, okay? Before we go any further, massive thank you to these guys over here who have subscribed to the channel and have commented. And if you want a shout out, make sure you subscribe, make sure you hit that like button as well, and we'll put you down at the beginning of the video, okay? Also remember that the practice question is going to be linked in the description below, so you can have a go at the questions and then you can mark them on as we go along with the video, okay? So without further ado, let's jump into it.
It was a nightmare.
Activate.
Okay, so we got question number 1 over here. It says, this question is about hydrocarbons. Most of the hydrocarbons in crude oil are alkanes, okay? Most of them are alkanes, so we need to remember that. Large alkane molecules can be cracked to produce more useful molecules. The equation shows the cracking of .cane, okay? So we have .cane here that has 12 carbons, right? And then once you do the once you do the cracking process on it, that long hydrocarbon chain is going to break down into these 3, okay? We got butane, we got hexene, and we got ethene, okay? Now, it says give 2 conditions used to crack large alkane molecules. So one of them is going to be that you're going to need a high temperature. There we go, high temperature. The second one that you need is that you can either use a catalyst or steam. And there you have it. Those are your 2 first marks in that question, okay? Now it says the product hexene, there you go, hexene, that will be an alkene. You got double E, so that means that that structure is going to have a double bond there somewhere, okay? Are alkenes. Complete the sentence. When alkenes react with bromine water, the color changes from orange to clear. That will be your answer, okay? When you have it in an alkene and you add bromine water to it, the bromine water is usually orange and it's going to change to a clear color, okay? Now over here is asking us to complete the rest of this diagram. It says butane C4H10 is an alkane. Alkane, okay? Alkane are used for fuels. Alkene are used in the manufacture of plastics. Right, complete the display structure for butane. Now, here it tells us there is 4 carbons. Over here we only have 2 carbons so far. So what we need to do is that you need to add 2 more carbons, right? And then it says that it should have 10 hydrogens. So right now we got 5. And there you have it. That is another mark for that, okay? 4 carbons and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. There we go. And that is that. Now we have question 1b. It says a group of students investigated the energy released by the combustion of 4 hydrocarbon fuels. The diagram below shows the apparatus used, okay? So this is what you have there. You have water, 100 centimeter cubes of water. You got a beaker and a thermometer to measure the temperature, okay? You have the spitter burner with the hydrocarbon fuel. So they would have 4 of these. Okay, they will have 4 of those, and each one of those will have a different hydrocarbon fuel inside of them. Okay, each hydrocarbon fuel was burned for 2 minutes. There we go. And this is the table of the results that they got. So you got the 4 hydrocarbon chains. You got hexane with 6 carbons, octane with 8, decane with 10, and dodecane with 12. The mass of fuel used in grams, that's how much they use, because they would weigh that at the beginning, they will write it down, and when they finish after the 2 minutes, they turn it off, they weigh it again, and that is the difference in mass. So that means that is how much grams of the fuel was used. So for hexane, they use 0.81, for octane, they use 1.10, and so on all the way down. The temperature increase of the water, that means that if you had a set temperature, for instance, maybe 20, the initial temperature of the water was 20, once it finished, the temperature had increased by 40 degrees, meaning that the temperature was started at 20 and finished at 60. This one here, it went up by 54. This one here, it went up by 58 and 67, okay? Now, the amount of energy released by the fuel in kilojoules is that. You got 16, 22, 24, and as you notice, it gets bigger as you go down the group, okay? Now, over here, the energy released by gram of fuel in kilojoules is this much. Now, these are some of the things that were observed. It was very little smoke in the first one, some smoke, it got smoky, and then the last one, the longest hydrocarbon chain, got very, very smoky, okay? Now, you want to notice a pattern here, that the amount of mass used gets bigger as you go down to the highest number of carbons. The temperature increase of the water also increase as you go down. The amount of energy released also gets bigger as you go down the group, and then the energy released by the fuel in kilojoules, it actually goes down as you go down the group, okay? So you want to keep an eye on this. Then you have your observations, okay? So it says here, calculate the energy released by 1 gram of decane in joules. So this here is what they're asking you, okay? They're asking you to calculate that. So how are you going to do that? So you get your calculator, okay, and you're gonna put in the following figure. So if the energy released by the fuel in kilojoules is 24.36, you're gonna type in 24.36, okay, and then you divide that by the mass in grams, which is 1.20, and that's gonna give you 20.3, okay? That's the amount of energy released per 1 gram in the answer, okay? So your answer down here, you would write 20.3. Now, if you notice, it's got 2 marks. If I just write the 20.3 and I got that right, I will get 2 marks, okay? However, if my answer is wrong, I would get 0 marks. So this is very important that you actually write down your working out, okay? Your working out has to be written down in a paper so you can get a mark for that one as well. So you're gonna write down 24.36 divided by 1.20, and that gives us 2.3, okay? So if you got the answer wrong by any means or for whatever reason, the working out here should give you 1 mark, okay? So always keep that in mind. Okay, so now we got question 1.1b.2, okay? So suggest an improvement to the apparatus or the use of the apparatus that would make the temperature increase of the water for each fuel more accurate. Okay, give your reasons why this is an improvement. Okay, so suggest 1 improvement. Okay, so you only have to suggest 1, and then you need to write down your reasons for why you done that. Okay, now the first thing that I would go to is that if you have a look at the diagram, okay, you have a look at the diagram here, when the heat is actually being released by the spirit burner, the energy is going to be released in every direction, okay? So see, every direction. And even if the energy goes into the water, if you notice here, the beaker is not insulated, so some of that energy is also going to escape down this way, okay? So you could say that you might want to have the beaker insulated to retain as much energy as possible within the actual beaker itself, or you could also have some sort of cover around the spirit burner so the energy gets focused upwards, okay, and all of it is heading towards the water, okay, not too much spread around the sides, right? So I would go for the following. Put a lid on the beaker and insulate the beaker to reduce energy loss, okay? So you get 1 mark for the idea of putting a lid or insulating the beaker, and 1 mark for the reason why, okay? Now, moving on to point 3, B.3, it says, the student noticed that at the bottom of the beaker became covered with a black substance when burning these fuels. Name the black substance and suggest why it is produced. Again, the black substance would be soot. Some of the carbon in the fuel did not burn and it was given out as black smoke. This is incomplete combustion, and this happens normally when you have long hydrocarbon chains, okay? And that will be another 2 marks. Okay, a student concluded that hexane is the best of 4 fuels. Give 2 reasons why the results in the table support this conclusion, right? So we're going to visit the table again, and here is hexane. Okay, so we got hexane over here. Okay, now the amount of energy released by every gram of it, okay, if you notice, hexane release the most amount of energy in each gram, right? That means that if you burn a gram of each one of those fuels, hexane is the one that's gonna give you actually the most energy. And also you have another reason here is very little smoke, okay? If you wanna be burning that, you wanna make sure that all the fuel is burning, all the energy is released at least as much as possible. That means that there will be less black smoke. And also here we can see that there was less fuel use during those 2 minutes than with every other fuel, right? Meaning that you actually are saving fuel and is giving more energy for the actual gram that you would have used instead, okay? So you got 3 possible options there to write from. Less fuel was used in grams. More energy is released by 1 gram of hexane. That will be your 2 marks right there, okay? Okay, so now we go to question 1b. In this question, you will be assessed on using good English, organizing the information clearly, and using specialist terms where appropriate. Most car engines use petrol as fuel. Petrol is produced from the fractional distillation of crude oil. Crude oil is a mixture of hydrocarbons. Sulfur is an impurity in crude oil. Now, then we have car engines could be developed to burn hydrogen fuel instead. Hydrogen is produced from natural gas, and natural gas is mainly methane. Now, table 2 shows that information about petrol and hydrogen. State of the fuel at room temperature, we got liquid, and then we have hydrogen gas. Word equation for the combustion of the fuel, petrol plus oxygen gives you carbon dioxide and water, and the hydrogen is hydrogen plus oxygen just gives you water. The energy released from the combustion of 1 gram of fuel is 47 kilojoules, and the hydrogen is 142 kilojoules. Describe the advantages and disadvantages of using hydrogen instead. Okay, you want to focus in this, using hydrogen instead of petrol in car engines. Use the information given and your knowledge and understanding to answer the following question, okay? This is a 6-mark question, and normally you could just do bullet points. However, the question is stating that you will be assessing good English and organizing your information clearly. So you want to make that into an actual sentence or a paragraph, okay? So you could write down a couple pros and cons in the side and then start writing your answer afterwards just to make your ideas a little bit more organized. So advantages and disadvantage. Well, let's go like this. Advantages, energy, and it's always nice to write down some figures, okay? 142 kilojoules. Whilst petrol, another thing that we can think about here is about the carbon dioxide, okay? Liquid petrol produces carbon dioxide while hydrogen gas only produces water. And also you need to remember that it has sulfur impurities. Petrol has sulfur impurities, and sulfur is one of the reasons that you get acid rain, okay? Because the sulfur mixes with the moisture in the atmosphere, creating an acid, right? So okay, so we got some advantages there. Now we want to write down a few disadvantages, okay? It doesn't matter whether you have same, 3 advantages, 3 disadvantages, as long as you also include it, because it's what the question is asking you as well, okay? Now, one disadvantage with hydrogen is that it's very difficult to extract, especially if it's extracted from the electrolysis of water. You're going to use a lot of energy to extract that hydrogen in the first place. And another reason is that it's a lot more difficult to transport because it is in a gas state. It requires a lot of pressure to keep in the containers, and they have to be handled with a little bit more care than the actual petrol, okay? So disadvantages. Now, another disadvantage would be that not a lot of vehicles right now are equipped with engines that can use hydrogen fuel, and also there's not a lot of refilling stations for hydrogen fuel at the moment. Okay, there we go. So you have a couple of ideas there. It would have taken you a few minutes, maybe 3 minutes to get those down. And but we wouldn't be able to leave it like this. You will have to organize these bits here and put them into an actual paragraph and put it into sentences, so you will be able to actually get all the marks that you will be looking at in this question, okay, to get 6 marks. Okay, now we're going to move into question number 2. It says the diagram shows an apparatus that can be used to carry out cracking reactions in the laboratory. Okay, so what we have here is you got paraffin is soaked into wool, so we got that there, is nice and warm, and aluminum oxide or broken porcelain is added to that test tube and is heated very, very, very strongly. Okay, once the reaction happens, the gases will travel to this tube. They're gonna go down here. Here we got some of the product A. Okay, and is submerged in cold water. That is because when the vapors go in here, okay, what would happen is that they're gonna cool down and it's gonna condense into a liquid, and then you have another delivery tube connected to it, and then we got gas being given off here, and that is product number 2. That means that one of those products is gonna end up turning into a liquid and the other one is gonna be turned into a gas. Okay, right, so let's see. Why is aluminum oxide or broken porcelains used? Okay, the reason why we use this is because they can become very, very hot, right, which actually induces the cracking to happen. Okay, because you need very high temperatures, so we could say that they are being added as a catalyst. They are used as catalysts. Paraffin contains decane. The cracking of decane can be represented by the equation below. A decane molecule is split into 2 smaller molecules. Complete the equation by adding the formula of the other product. Okay, so let's have a look. Whatever you put into the reaction has to be the same amount of atoms that come out of the reaction. Okay, so if you have 22 hydrogens and 10 carbons, in that one product you got 2 carbons and 4 hydrogens. So how much do you need to make the total amount? So for instance, right, if you add another 8 carbons, you have 10, so that will have to be 8. And for the hydrogens, you got 4 over here, and in order to make 22, you're gonna need 18 more carbons. Okay, so that will be your answer for that. Easy peasy. That's another mark. Thank you very much. You would expect C2H4 molecules to collect at a position A or B on the diagram, right? So write down the position and express your answer. Now remember that before in fractional distillation we said that the smaller hydrocarbon chains, this one has only got 2 carbons, while this one has 1, 2, 3, 4, 5, 6, 7, 8. All right, that long hydrocarbon chain, all right, will condense a lot faster than this one because this one is smaller. So if we look at that, one of them has turned into a liquid because it got cooled down, whilst the other one, even though here is a bit cooler, it still was able to travel up there and continue being a gas. So essentially we would say that this molecule here, C2H4, will actually be collected at point B, and the reason for that is because it's a smaller hydrocarbon chain and it needs less energy to be turned into a gas. Or you could also say that, or you can say that it just has a lower boiling point. That's why it's still a gas and it will be collected in position B. Okay, so cracking reactions involve thermal decomposition. Okay, let's have a look at this question. There you have it. What is meant by thermal decomposition? Okay, when you think about thermal, you think about heat. And decomposition, breaking down. Breaking down. There you go. Right? So, essentially, thermal decomposition is using thermal energy to break something down. Question E. Explain as fully as you can why cracking is used in the oil industry. To gain full marks in this question, you should write your ideas in good English, put them into a sensible order, and use the correct scientific words. Okay, so first of all, you would say that long hydrocarbon chains are not very in demand. Okay, breaking them down into smaller chains is better because they are more useful. Some alkenes from cracking hydrocarbons are used to make plastics. And small hydrocarbon chains ignite easier. Okay, so this is some of the things that you want to write down when it comes to that question. I've written 4 different points, although the question is only 3 marks, just in case we can have that extra one there. Okay, now the cracking reaction produces a mixture of products. The mixture contains hydrocarbons with different boiling points, suggest a method of separating this mixture. Okay, so even though it's not actual crude oil, it is still a combination of hydrocarbons with different boiling points. So the technique that we use for that is fractional distillation. Okay, and there you have it. Okay, question number 3. One reason that oil industry is important is that it uses crude oil to produce many of the plastic materials we use in every day. Okay, the first stage of in the formation of plastics is called cracking. Butane C4H10, a hydrocarbon in crude oil, can be cracked to produce 2 different hydrocarbons, ethane and ethene. Okay, ethane and ethene. One of them is an alkane and the other one is an alkene. For cracking to happen, what needs to be done to the hydrocarbons? Okay, those are the 2 things. Hydrocarbons need to be heated, okay, to very high temperatures, and a catalyst can also be used, just like in the examples that we had before, and that's going to give you your 2 marks. Okay, complete the equation for the cracking of butane using the display formula. Okay, now over here, this is the ethane. Okay, so that is an alkane. That's only going to have single bonds in them. Okay, so we have 2 carbons, 1, 2, and each carbon can be attached to 3 hydrogens, and that's the first part. Then now ethene is an alkene, and if you see that there's a double E, that means that somewhere in that molecule there's going to be a double bond. Okay, and there you have it. That will be the alkene. This one here will be used as fuel, and this one here is going to be used in the manufacture of plastics. Okay, complete the balanced chemical equation for the complete combustion of ethane and in oxygen. Okay, so ethane is given to you here. I think that's missing, there you go, missing the H there. So we're going to do that in the presence of oxygen, and as a result, we're going to have carbon dioxide, and you're also going to get water. Okay, to balance this chemical equation, you will have to go through the long process. Normally, I don't tend to put too much attention into this because normally there will be 1 mark, but this one in this case is going to be a 3-mark question. Okay, so we can start working now. I'll show you down here how to do that. So if we have, I do have a video on balancing the equation. I'll put it up here so you can click on the link and have a guide through it, but I'm just going to write this down very quickly so you can actually have a look at it. You can press pause and have a look where the numbers came from. Okay, okay, so up here we can leave that empty, right? Or we can just write 1. Carbon and oxygens are gonna need it be 3. Carbon dioxide you're gonna have 2, and water molecules you're also going to have 2. Okay, there's other ways of doing it, but this is the way that I find it the easiest. Okay, now 3b, the second stage in the formation of plastic material is by polymerization. Describe how ethene forms polyethylene. You do not need to give the reaction conditions or the names of catalysts. Okay, okay, so the first step is that the double bonds open. So the double bonds here are gonna open, and then you're gonna end up with the carbons being able to connect into the other side. Okay, step number 2, it says many of the hydrocarbons, C2H4, do this. And number 3, Okay, so this means that there are going to be many of those hydrocarbons who are going to be joining in together. So you could have another carbon molecule joining here, and then you can have another one joining over here as well, and so on. And that chain can be endless. Okay, you can have loads and loads and loads of those joining together. But that is essentially what polymerization is. You're going to have many monomers joining together, making a long chain. Okay, and that's going to be your marks there. Okay. Well, there you have it, guys. That was a bit of exam questions on the topic on chapter 9, cracking. And if you have any specific requests, please drop us a comment, and then I'll try to get a video on those down as well. So until then, remember, knowledge is power. See you next time.